limit theorem and how the sample means are surrounding population mean, the sample mean deviating from population mean. I have told you the standard deviation, standard error, and standard error of mean difference, all the three different terms. And here, standard error indicating the deviations of sample means from population mean. And similarly, the sample mean differences are also deviating from the mean, to which you call as standard error of difference among means or mean difference. So we are using t-test, which is a test indicating difference between two groups or two samples. So as you know, the sample we are choosing from the population cannot be exactly like population. It must have some difference due to sample fluctuation or sampling error. And this uh, deviation we calculate in terms of standard deviation. And actually, uh, in that sense also, we say that the standard error is indicating the deviations of the samples among themselves from the population. And also, in standard error of difference indicates the sample means are all different and their differences are normally distributed. And that deviation is indicating sample or standard error of mean difference. So here in t-test, we can easily go to the formula that we take two samples and the samples could be large sample, small sample. When the sample is very large, then the t value would be equivalent to z value. So in the in the population, z is a parameter, but t is a 36. And the t will be approximate to z, the sample is very large. But still, the sample is large, which means more than 30, and 30 or less, that is 36, small sample. But when it is more than 30, we consider this as large sample, bit large. So actually, in that case, the large samples, the formula could be little different. Or we can, same formula we can apply, but for large sample and small sample, we can also use different formula. But the thing is, the sample, whether large or small, could be independent sample. Independent sample means both the subjects in both the groups may not be same or may not be similar, maybe something different. So independent choice. So now if the sample, both the samples are independent, then the method for calculating the t value is different. And the t value will be sample mean or mean number 1, difference mean number 2 divided by standard error of mean difference. And in case of other type of sample, when the sample is, the individuals are repeated. Suppose you are making a test, again you are retesting. The same people are repeated. You have made a test on the subjects. Those subjects are retested. So now, since the subjects are common, we say it is a correlated t-test because test 1, test 2, they are correlated, they are related. So now the formula for sample independent is different and some formula for sample related, either repeated or equivalent. Or for example, somebody from the family, same family, brother and sister, brother and two brothers of the same family, they're related. So when the samples are related, we make correlated t-test. The samples are different or independent, then we can call it as uncorrelated t-test. So the formula is different. For uncorrelated t-test, I told you that we just get mean one, mean two difference divided by the standard error of difference or SED that you can find out. And in case of the small test, we could go for another method also, but not necessarily. And in case of quality test, the calculation is different. In core, so the thing is, in both the cases, we take both the means difference, mean one difference, mean two difference. The divide the SED, or you can say standard mean difference. The formula is separate for independent t-test. The formula is separate for the correlated t-test. For correlated t-test, the formula is standard error of mean 1 or standard error of mean 2 minus 2 ABC formula, like a square plus b, a square minus b, a minus b whole square, a square plus b square minus 2ab. Similarly, in this, that is 1. So you take it is given in the book. You can see the formula is something different. So you can take the correlation. If since both are correlated, you first of all you get the coefficient of correlation, the R value, and then you can make it like that. So a plus a that is standard of mean 1 square, standard of mean 2 square minus 2 standard of mean 1 and mean 2. That is formula. Because here just you can remember that like this a minus b the whole square formula, a square minus b square, a plus b square minus 2ab. That formula is there. So you can get in the book. I'm just trying to find out what I'm not getting easily now. So my 10. So here those here you just the main thing is here in t-test you have to remember you have to remember three things. First of all, you must know how to find out the standard error of mean difference. So after you get that, then you can easily get out the t value. So t value indicates the difference between two means divided by standard error of mean difference. Then you take the value to test whether it is significant or not. To test significance. So two things you have to remember. First of all, you should go to the level of significance. You have to fix up the label. But what label you have to accept or reject. So ordinarily, we accept any value. I mean, if the difference is significant, if the difference is more than or is significant at 0.05 level, then we accept the value is significant. If the value is more than 0.05, if probability is more than 0.05, then we say the null hypothesis is correct and the difference is not significant. And if the probability is less than 0.05 significant and less than 0.01, so we can say it is very highly significant. So now we take the hypothesis, null hypothesis or alternative hypothesis to see whether the difference is significant or not. And before going to test the significance, we go to T table, and there we first collect the degrees of freedom. The degrees of freedom is something also different for correlated and uncorrelated t-test. In uncorrelated t-test, we can say there are two independent sample means. In correlated t-test, there are two dependent sample means. If both are related, there are two dependent sample means. And the degree of freedom is N1 plus N2, as you know, in degree of freedom, in case of this uncorrelated t-test, as you know, it is actually always n minus 1. N minus 1 in degree of freedom. So in two cases, there are two groups, two samples. So N1 minus 1 plus N2 minus 1. The other degree of freedom. And here, in case of that is n minus 1 in case of uncorrelated test, but in case of correlated test, it is n minus 2, because you will check in the book is given, you will check on the book. As I told you yesterday, the degree of freedom indicates the constraints on the choice of the researcher. So I told you yesterday that you have 4 cases, you are liberal as a 3, but the last one you are bound by limitation. I gave you the example. Suppose you are having some sweets to distribute, so you can distribute as many you like, but when the last case occurs, you have to distribute because your choice is limited, because you can only distribute the remnants, not anything you like. So always n minus 1. But here, actually, the degree of freedom, you say that is in case of, you check that, always we remember the n minus 1 is the degree of freedom, or the degree of freedom is always n minus 1. In your correlation test, we make it n by 2, n minus 2, because it's a pair. But actually here, we always take n minus 1 as the degree of freedom. And you take the value, t value, and take it in the method of testing. You take the table, and there you see whether it is significant or not. If the t value, so in the independent variable, it's n minus 1, as I told you, degree of freedom. So you see, with this degree of freedom, the t value in the table, if if the table value is less than the value you have received, I mean the calculated value, if the value calculated is more than the table value, you say it is significant. If the value calculated less than table value, you say it is insignificant. Insignificant means the null hypothesis is accepted. Means there is no difference. Or if there is a difference, the difference is a matter of chance. But on the other hand, if the difference is significant, you can say that the value the difference is significant, which means both the groups, they are different, or they are having their means differ significantly. So the question is, when there is a difference, you could say that these values, these two groups, or the individuals in both the samples, they are actually, now the question is whether they are from the same sample or whether they are from the sample of other population. So the difference indicates that both the samples are different, because the means are different. And the samples should not be different if they have been drawn from the same population. So if from the same population, two samples have been drawn, then it is presumed that their means should not be different. There may be chance difference, but not significant difference. Now the question is, if it is different, then the sample is drawn erroneously, number one. Or number two, the sample is not for the same population. maybe from the another population. So therefore the difference is like this. So you can make conclusion like this. So with degree of freedom, that is n minus 1 is so, and here n by 2 in correlation method, degree of freedom n by 2, n minus 2, you also check it that whether this value is significant or not. So here you say about the means and about the sample by taking the significance level. So t test basically indicating the difference between two means. Two means mean two groups. If both the means are different, then actually we say that both the groups are different. Or either, as I told you, either they are erroneously taken for the same population or they are taken from a different population. So now, when you are having two groups in comparison or two means in comparison, we are usually taking the t test, which is called as test of significance of difference between means. But when you are comparing three means or three groups, then the t test is not a good test. Then we take another test called F test, or we say test of variance. So that is analysis of variance or F test. Suppose we are taking two groups like boys group, girls group. Then we want to see if the boys and girls are different. Then you can take this T test. Also, you can do it in F test. F test is a better test, more reliable, much better, higher test. And here we take the F value as the variance between the means and the variance within the groups. I mean, when the sample are there, so sample 1, 10 cases, sample 2, 10 cases. Now, please remember the between concept and within concept. So, between means, so when the two groups, then two groups differ. That difference is between group difference. But in in the two groups, in each group there are 10 persons. Then the 10 persons also differ among themselves. That is within difference. So a group difference and individual difference. So the group difference that is between group is the group difference divided by the within groups. But the difference between within the individuals or individual, that is difference within the individual. So that is inter difference and inter difference, like that. So intergroup differences and inter differences. So that becomes the variance, and the differences are variations. So the variance between the group and the variance within the group, that indicates the F ratio or the F value. I mean the analysis of variance value is measured by the comparison of variance, that is introvariance, between variance and within variance. So between by within, that gives you the F value, and the variance, as you know, we know the standard deviation, and variance is something like square of standard deviation, or you can say in terminology of statistics, the distance of scores from the center or the mean is deviation, or index of variability. We can say it mean deviation or standard deviation. And actually the variance is actually the square of the variation. So we can say the characteristics of variance. The variance is the measure of variability, which indicates the among groups or between groups differences as well as the within group differences. The variance is always in plus sign. It's a difference. The variance is like an area. The scores on normal curve are shown in terms of units, but in variance it is shown as area. The variance remains the same by adding or subtracting a constant in a set of data. So here the variance, as I told you, is a stable measure of the difference, and here we get the variance from the data. Like suppose example, group of score like group A score, group of score like group B score, and a group of score like group C score. There are three groups: A group, B group, C group. So each group has 10 cases, and you take the scores, you take the square, and to the square, all the squares added, and all the scores added. These scores are added and square divided by n. We take a term called correction term. That is called correction term. The total of square minus correction value, it gives you total variance. Similarly, between groups, the group, total group divided by the n square minus this sum of total square minus this, it gives you between square. The total minus between gives you within square. So like this we get. It's a different formula also there is given. You apply formula, you get total sum of square, you get between sum of square, you get within sum of square, and always you will find cross-checking that within plus between will be always like total. It will be added, it will be total. And here you take the mean sum of squares in within group, mean sum of squares in between group, and the mean between sum of squares, that is the mean sum of squares within, between or among mean sum of squares or between mean sum of squares divided by the degree of freedom. Suppose there are two groups, then the degree of freedom will be k minus 1. K means treatment. K means treatment. Suppose there are two treatments, so degree of freedom will be k minus 1, that is 1, or there were three treatments, so 3 minus 1, 2. Similarly, within groups is the variation within the subjects, that is like variations, and you take the mean within variance divided by total number of cases minus the treatment. Suppose there are 10 cases, so 3 groups, so 30 cases, 10, 10, 10, 30 cases, but 3 groups, so k is 3, so the degrees of freedom will be n minus k, that is you see 3 groups, 30 minus k, 30 minus 3. So here the within sum of squares by within variance divided by n minus k, like 27, 13 minus 3. So that will give the mean sum of square. So the mean sum of square in the between group or among group divided by the mean sum of square of within group, that ratio is called F ratio. And the F ratio is the ratio which indicates the difference among the groups, and this ratio has been also checked in the table, F table. And here when you check the table, you take the degrees of freedom in one side and the degree of freedom of within in one side. So between by within, so you take this one thing horizontally between degree of freedom, and this column wise or vertically you check this the within degree of freedom. So from this both degree of freedom you can get the significance value, and that is 0.5 label. You can get the value given in the table. So if your value F value is more than that table value, you say it is significant. Then when it is significant, we say these two groups, they differ significantly. Sometimes this is in one factor. Suppose you are saying we are giving good well coaching. Such coaching given to different groups, and one group is giving coaching, other group is not giving coaching. Or you can say both the groups are giving coaching, whether they are different or not, both the three groups. So if F is significant, we say this coaching has significant effect in achievement. So if it is not significant, we can say the coaching has not significant, has no effect on achievement. So now like this, here it is one factor we are dealing with. So it is called as one way of analysis of variance, or one way analysis of variance, or you can say the ANOVA, one way, because we are going to study the effect of one factor. Sometimes there are two factors, and the two factors are we can study not only one factor, we can also study two factors. That is called two-way analysis of variance. So let me tell you, the F test and T test, both are testing the difference of groups, but both the test, F test and T test, they are complementary to each other. T is followed when F value is significant. F is followed when T value is not significant. Sometimes T is not significant. You can again check with F test. So there is a fixed relationship between T and F. Usually the F is the square of T value, or you can say the T is square root of F value. So T and F, they are usually variables related, and the analysis of variance or F test have certain merits or advantages. Number
एक्सक्यूज मी, यार कुछ बोला है? हेलो
यस
यार କିଛି କହିଲି କହିକି ଗଲେ କି?
ନା ନା କିଛି କହିନାହାନ୍ତି
ଆଜ୍ଞା
କିଛି କହିନାହାନ୍ତି ହଠାତ୍ ତାଙ୍କର ମାନେ ଭିଡିଓ ଅଫ୍ ହେଲା।
ଆଚ୍ଛା ମତେ ଟିକେ ଅପେକ୍ଷା କରନ୍ତୁ, ଠିକ ଅଛି?
ओके
Everybody should wait, please.
ओके ओके
ଆଚ୍ଛା ପିଲାମାନେ ମୁଁ କହି ଚାଲିଛି କେହି ଶୁଣୁନ କଟିଯାଇଛି ମତେ କଣ ବିନୟ ବାବୁ ଫୋନ କରି କହିଲେ। ହ୍ୟାଲୋ ହ୍ୟାଲୋ
हेलो
ମତେ କେହି କହୁନ ମୁଁ କହି ଚାଲିଛି କଟିଯାଇଛି ଏଇଟା ଲିଙ୍କଟା।
ଆଜ୍ଞା
ମତେ କେହି
ଆମକୁ
ରିମାଇଣ୍ଡ କରୁନ। କେତେ ସମୟ
ହେଲେ
ଗଲାଣି?
15 ମିନିଟ୍ ହବ,
ଆଁ
15-20 ମିନିଟ୍ ହବ।
ମତେ କେହି କହୁନ କେହି। ମୁଁ ତୁମକୁ କେତେ ପଢେଇ ସାରିଲିଣି। ଆରେ କେହି ତ କହୁନ ମତେ କଣ କହିଲ କଣ କଣ ତ ପଢଉଥିଲି ମୁଁ କୋଉଠି ତମେ ଲିଙ୍କ ଥିଲ? କୋଉଠି ଲିଙ୍କରେ ଥିଲ? ମୁଁ ଲାଷ୍ଟ କଣ ପଢଉଥିଲି? ହ୍ୟାଲୋ 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 ଆରେ କୋଉଠି ମୁଁ କୋଉଠି ମୁଁ ରହିଥିଲି ତୁମ କୋଉଠୁ କନେକ୍ଟ କଟିଯାଇଛି? ଡକ୍ଟର ରୁଚା Dr. Rucha,
Yes, sir.
are you hearing me?
Yes, sir.
ତମେ ଥିଲ ତୁମେ କୋଉଠି କଟିଛି ଆମର ଲିଙ୍କ ଟା କଣ ପଢୁଥିଲି ମୁଁ
Sir, F ର ଯୋଉ value ସେଇଟା ପଢଉଥିଲେ sir.
କଣ ପଢୁଥିଲି ଆରେ କଣ ତୁମେ ଦେଖିଛି ମନ ରଖିନ ବୋଧେ ମୁଁ ଯୋଉ ପଢୁଥିଲି କୋଉଟା ପଢୁଥିଲି ମୁଁ ଜୟପାଲ
सर टी टेस्ट एफ टेस्ट कोरिलेशन विषय कहते सर
ଓ ସେଠୁ ରହିନି ମୁଁ ତାପରେ ଆଜି ଗୋଟେ ଚାପ୍ଟର ସାରି ସାରିଣି
हाँ सर सेठू कटि जाइए
ମଝିରେ disconnect ହେଇଯାଇଥିଲା sir.
ମତେ ଟିକେ ଫୋନ କଲନି ମୋ ନମ୍ବର ତ ଜାଣିଛ କରିଦେଲି ଫୋନ ଆରେ ଏଇ ପିପୁଲ ଆର ଅଲ୍ କ୍ୟାଲସ୍ ମୁଁ କହି ଚାଲିଛି ମୁଁ ଗୋଟେ ଚାପ୍ଟର ପାଇଁ କବାକୁ ଚାହେଁନି ହଁ ଶୁଣ ତୁମର ମୁଁ କହୁଥିଲି କୋରିଲେଟିଭ ଟେଷ୍ଟ ଅନକୋରିଲେଟିଭ ଟେଷ୍ଟ ଆଉ ତ ମୁଁ ରିଭାଇଜ କରୁଛି ବ୍ରିଫଲି in uncorrelated test and in correlative test in both the cases we make mean 1 minus mean 2 difference divided by standard error of mean difference तुम्हारा ये जो correlative test रे standard error of mean difference ता फॉर्मूला अलग है जैसे हमें a minus b रो होल स्क्वायर कहू a square plus b square minus 2ab से भली यार सब हुए कौन ना स्टैंडर्ड ऑफ मीन 1 और स्टैंडर्ड ऑफ टेम्पल 1 स्टैंडर्ड ऑफ सैंपल 2 माइनस 2 into स्टैंडर्ड ऑफ सैंपल 1 सैंपल 2 स्क्वायर रूट हमें कहू a square plus b square minus 2ab इट a square plus b square minus root 2ab इधर फॉर्मूला इटा यही फॉर्मूला बाहर तारो स्टैंडर्ड एरर ऑफ मीन डिफरेंस आउ कोरिलेटेड ये तार बाहर स्टैंडर्ड एरर ऑफ 1 n minus by n1 that is square root and here also standard error of sample 2 square root by n2 तांगर बाहर फॉर्मूला अलग अच्छी बही देसबू तो by taking formula we get the two values that is one for independent sample that is t value and the other is correlated sample that is t value. A correlative test is a correlative test when the test is repeated or the sample is matched. For example, गोटे टेस्ट कर पुणी रिटेस्ट कर sample repeated एटा है correlative test बा गोटे टेस्ट कर गोटे ग्रुप तापर आ गोटे ग्रुप तो नहीं मैचिंग पेयर नहीं से भी है correlative test तेणु कोरिलेटिव टेस्ट आउ अनकोरिलेटिव टेस्ट इटा कला पर तुम जो वैल्यू पाइल से वैल्यू को तुम लेकरी गोटे टी टेबुल रे चेक करिवो विथ डिग्री ऑफ फ्रीडम हमर डिग्री ऑफ फ्रीडम हमर जो अनकोरिलेटिव टेस्ट रे हुए इटा हमर n-1 मेथड एप्लीकेबल इट n-2 एप्लीकेबल अच्छा तुमरो you take the degree of freedom in both the cases and with that degree of freedom you check the t value. If the t value is significant at 0.5 level or your obtained t value is more than the table t value, then you say it is significant. Then you say that both the group differ significantly. And now the question is, when both the groups are different or you say differing significantly, this means both the groups have been taken from two different populations. If not, if you say now that's from the same population, if from the same population, you can say maybe there is sampling errors in choosing the sample or sampling fluctuation in choosing samples. So now you can say that the t value indicating a difference, whether it is chance difference or whether it is a significant difference. So the null hypothesis tells about the chance difference, is no difference or chance difference, and the alternate hypothesis tells about the significant difference. So accordingly, you conclude whether the means are different or not. So now I come to the F test. The F test is a higher test, and the F test is applicable when the groups are more than two. When there are two groups like sample 1, sample 2, then the t-test is only applicable. But when the groups are more than 2, so that could be f-test. The f-test could be of two types, you see. One is simple ANOVA or a one-way analysis of variance. Other is 2 into 2 ANOVA, or you can say two-way analysis of variance. The analysis of variance, as the name indicates, so here we take variance into account to indicate the significance of effect. In the t-test, we take standard deviation, but in the f-test, we take variance. So variance is the square of standard deviation, or the deviation that we're taking at the advanced AD or ST, the variability. So now see, the variance has no plus or minus sign. So it variance only indicates an area. So the variance actually indicates that whether the particular sample you have taken is approximately in the same with the population or also different. And also you can say whether the sample you have taken in the test, whether two samples differ significantly or not, whether one particular factor which is going to affect the sample, whether the factor affecting significantly or not significantly, or whether there are two factors, or the two factors whether they are affecting significant or they are different or not, having different effect or not, or even the interaction effect of the two factor significant or not. So all these things are being calculated from the test of analysis of variance. And the analysis of variance, you know, it is the f test f value, and the f value and t value, they are very complementing. They are not very different also. It is also it is seen that the t value, the square of the t value is equal to f value, or t square is equal to f. I mean the f value and t value, they have been interrelated. So the f value is used to show the significance of effect of one factor or two factor or also multi-factors. So f test is also a higher test, is more reliable a test, more usable a test, and frequently used in parametric statistics. And the f test, as you know, here in one way analysis variance, we say that we take the scores, we take the square, and we make the total sum. So their square divided by n, that term becomes correlation term. So the total sum of squares minus correlation term becomes total sum of square. The same formula also applicable in 2 into 2 analysis variance or two-factor design. And also here, in one way, we are having the among variance or between variance. Then we are having the within variance or error variance. So between by within, the value between by within, the mean sum of squares, mean sum of between sum of squares, divided by mean sum of within sum of squares, that gives the f value. But in two-way analysis variance, we are having that between sum of squares, within sum of squares. Also at the same time, we are having another sum of square, that is A and B, that is interaction sum of squares, interaction effect. So apart from getting A effect, apart from getting B effect, we also get A into B effect, that is A and B interaction effect. So in 2 into 2 group design or two-way analysis of variance, we get an extra statistical effect, that is interaction effect. So which is very much necessary in higher statistical analysis and in studying different behavioral analysis. We are always very much lured by these interaction effects. So now I can tell you in the analysis of variance, as you know, we are able to know the effectiveness of one factor, one variable. But now in two-way analysis of variance, we are having more effects. I am going to tell you the merits and demerits of two-way analysis variance. So now you see, number one, the technique we use in two-way analysis variance. There you find the main effect and the interaction effect. So two significant things we find here, the main effect and interaction effect. Secondly, more than two factors are analyzed by this technique. Well, not only two factors, more than two can be analyzed. And thirdly, this two-way analysis variance is used. This two-way analysis variance is used for analyzing the data on the basis of factorial design. This technique is used. This technique is used to analyze the data for complex experimental studies also. Thus, the two-way ANOVA is having a lot of advantages and used in different ways. There are also some demerits or limitations. When there are more than two classifications, more than two, F ratio provides a global picture of difference. The inference can be specified by using t-test in case when F ratio is found significant for a treatment. To specify the effect, you can use t-value even if there is significant F ratio. So secondly, this technique also follows the assumption on which the way analysis variance is based. If these assumptions are not fulfilled, the use of this technique may give us spurious results. Thirdly, this technique is difficult and time consuming. And fourthly, as the number of factors are increased, the complexity of analysis also increased and the interpretation becomes difficult. And lastly, this technique of 2 ANOVA requires high level arithmetical and calculative ability. Similarly, it requires high level of imaginative and logical ability also to interpret. So, it has both the merits and demerits. So you can say that it is a complex technique, not as simple as one-way ANOVA, and it's difficult, but still then it is useful for the statistical analysis. So in this way, I complete the statistical portion. So again, I now come to the other portion, that is research portion. So are you all clear on the statistical side? Are you all clear about the portion in this MPC-006 statistics portion? Any doubt? So tell me if you have any doubt about the statistical portion, because now I will again go back to the research methods. I have to complete. Tell me any doubt?
No, sir.
Any doubt?
No, sir.
ମୁଁ ପଚାରିଲେ ସବୁ କହିପାରିବ? ଆଚ୍ଛା ମତେ କହିଲ ଗୋଟେ ଜିନିଷ, ଯଦି if there are two groups, two samples, we are using to see the difference between two samples, we are using what type of test?
T-test, sir.
T-test, sir.
T-test. Very good, very good,
T-test.
very good. And if it is more than two tests, we are going to use F-test. And F-test are of how many types? One way, two way. That also I've told you. And here, the T-test is having two types of test. What are the different types of test? T-test? Quick. Tell me the types of T-test. T-test. Uncorrelated and correlated. Could you get me or not?
Yes, sir.
The t-test could be used in two ways, like uncorrelated, correlated. If the observations are independent, we say uncorrelated. If observations are dependent, that is correlated. So correlated t-test can be of two types, in two ways also, mainly. What is that? Yes, Kaho? Yes. So one, if repeated, the same subject repeated, half yearly examination, final examination. The same students repeated. So in case of repetition, correlated test. Another, in case of matching, if the cases are matching, so it is a correlated test. So that you have to remember. And also the t value approximately becomes same with the z value when the sample size becomes larger, and the t value is calculated also different ways. If it is small sample and large sample, and how can you say a sample is small? What should be the size of sample? Any answer? When can you see, or when can you say that a sample is a small sample? When? Can you say? The sample is a small sample. Anybody? When the sample size or n number of cases will be how many? I told, if it is more than 30, we say large. Even 30 or less, we say it is small sample. ମୁଁ କହିଥିଲି ସବୁ ଭୁଲି ଯାଉଛ। Anyway, ତମେ ତ ସବୁ କହୁଛ ବୁଝ ବୋଲି କହିପାରୁନ ଆଉ। Anything will you ask me? I have told you the difference between field test, experimental design, ex post facto design, or field study or field test. Everything I have told in your research method. So now I have to come to a new chapter. Are you all prepared? Are you all prepared for the other portion? Or you want to take time in discussing doubts in statistics? Be quick. The statistics portion is covered. So now you can ask me if you like anything. If you don't like, I will go to the methodology.
So we can start the next chapter, sir. Please give us some time. We'll go through the statistics chapter what you have taught. If any doubts come, can we discuss in another class?
That will be, you can tell to the coordinator. You can speak to Binoy Babu. If he can like, he can arrange a class for
Okay, sir.
further clarification. But I cannot say like this. If he says, I can communicate to you all. If I have your numbers, I can communicate. But today, would you like to ask me anything on the statistics portion?
So we can start next chapter, sir.
So should I go to the left out portion of method, or should I wait for the statistical discussion still more? So in statistics, I am again going to rebrief you. In
Then
statistics,
we'll discuss with the coordinator and we'll again, if possible, we'll again arrange a class.
okay, good. But in statistics, you remember many important things. Like one is the scale you are using, like nominal, ordinal, interval, ratio scale, and the type of statistics, parametric, non-parametric. Again, the type of statistics, descriptive, inferential. What are the differences? And in the descriptive statistics, what are the groups? In inferential, what are the groups? In parametrics, what are the statistics? Non-parametric, what are the statistics? What is the difference between parametric and non-parametric? What are the assumptions? When you can choose parametric, when you can choose non-parametric, what are the assumptions? So these things you remember. Then you come to the, what is the correlation? What is Pearson R? What is Spearman R or rho? Rank difference correlation or Pearson's proton moment correlation. So what is Tyndall's test? There is, you can just go to different types of correlation. Then you come to the t-test. What is t-test? What is this central limit theorem? What is standard error? What is standard of mean? What is standard of mean difference? These concepts. So then you come to t-test, different types of t-test. Uncorrelated, correlated. How can you apply that? What is the degrees of freedom? How the degrees of freedom are different here? And how the degree of freedom helps you to measure the level of significance. You should know that. Then you come to the F-test. Why you are using F-test? You were using t-test. Why F-test? So, because the number of, even if there are 2 groups who are doing t-test. 3 groups who are going to use F-test. Even F-test can be used in 2 groups. It's a higher method, higher test. T-test cannot be used in 3 groups. But F-test can be used in either. F-test is a higher test. It can be used in 3 treatment, 4 treatment. Multiple factors are there. F-test can be used. And then also in one F-test, I mean ANOVA, one way or one factor F-test, 2 factor test or multi-factor test F-test. In here, in one factor, we are going to study about the significance effect of one factor. In this 2 into 2, we are using the study to know the significance of 2 factors, main factor, then also their interaction. That is the statistics, that is all over. Then we come to the other portion, that is leftover portion of this method. So here, in such method, you have been covered with you have been taught with different portions like what is research, the objective of research, the criteria of good research, the qualities of good research. Then also you have gone to the basic considerations of research like context discovery and context of justification. Then we have gone to different steps in research like step 1, step 2, step 3, step 4, step 5, step 6, step 8, like identification problem, formulating hypothesis, identifying variables, formulating design, constructing the measurement, then also data analysis, then drawing conclusion and report writing. So all these steps we have discussed. Then also we have come to other portions. That is unit 1, unit 2, you have gone to other portions. So different type of, that is criteria of good research. Research design, that is type of research, that is experimental design, ex post facto. Also we have come to the other unit like survey research. What is survey? Types of survey. So all these things, advantages and disadvantages of survey, steps in survey. So difficulties we were confronting the survey technique. So advantage, disadvantage, everything we have taken. And also in research we have gone through different forms of design, about design. Different forms we have covered. One, the design is ex post facto or experimental or field study. Then also we have come to post hoc fallacy, everything we have covered. So also we have now we will come to, we have gone also case study. We have seen the case study. I have told you the relevance of case study, and here the nature of the case study, the criteria for selection of the case study. I have told you the types of case study. I have told you the steps for case study. So now I will tell you the ways of case studies. Actually, the case study, I'm just going to take the chapter. Yes. So the types of case study, I've told you: illustrative case study, exploratory case study, cumulative case study, and critical case studies. I've told you the types. I've told you the steps also in the case study. So determining the present status, identifying the most probable antecedents, thirdly verification of the antecedents, fourthly diagnosis, and lastly follow up with the case of or cases. I also have told you the ways of case studies, like writing analysis of case study, panel experts, analysis of similar case studies, and cross-examination. These are the ways of case studies. So now I will tell you only one thing, that the misconceptions about case study. There is little misconception about the case study for using in research work. There are usually 5 misconceptions. So generally, theoretical knowledge is more valuable than concrete, because one cannot generalize on the basis of individual case, and therefore the case study cannot contribute to scientific development. This means by looking into one case, it is difficult to conclude generally. Second, the case study is most useful for generating hypotheses, whereas other methods are more suitable for hypothesis testing and theory building. Thirdly, case study may affect the basis, the bias, tendency towards verification, tendency to confirm researchers' preconceived notion. And lastly, sometimes it is difficult to summarize and develop general propositions and theories on the basis of specific case studies. So these are all about case studies. So then you come to research design, and here the designs are, as I told you, single factor design. And single factor design, actually, I have told you that is one way analysis variance, like then factorial designs, different factors, then quasi-experimental design, then other designs. Then single factor design, I have told you the functions of a research design. The research design helps us in different ways. Research design, the meaning as it indicates, is a plan, structure, and strategy of an investigation. And the function of research design is to provide answer to research question. Secondly, to control variance. And also, the research design, here research problems are treated in the form of hypothesis. The research design guides the researcher how to collect the data for testing the hypothesis. The main function of the research design is to control variance. The statistical principle behind the mechanism is Maximian principle, that is, maximize systematic variance, control extraneous variance, and minimize error variance. The design will be such that the real variance will be maximized. That is called maximize systematic variance, and to control the extraneous variance and to minimize the error variance. And here the basic terminology in research designs are there are three terms. One is factor, the independent variable of an experiment are known as the factor of the experiment. An experiment always has at least one factor. It could be having two factor, three factor, but at least one factor will be there. Secondly, a design also has the labels. A label is a particular value. A label is a particular value of an independent variable. An independent variable has at least two labels. For example, if we intended to see the effect of reward on verbal learning, then the reward is the factor and it has two labels, whether reward or no reward. So the labels will be there, two labels are there. So the design also involves labels. Some labels are there. And thirdly, treatment. The design refers to a particular set of experimental condition. For example, it may be 2x2 factorial design or factorial experiment having 4 treatments. 2x2 means suppose factor A having 2 treatments, A1, A2, factor B having 2 treatments, B1, B2. Similarly, 2x2 means there are 4 treatments. So we will have the design called single factor design when you are having between group and within group, as we found in one way analysis variance between and within. So between group design can have 2 randomized group design or can have multiple design. The most common method of randomly assigning the subjects in the 2 groups is to use the table of random number, that randomized design. In 2 randomized group design, the t-test or Mann-Whitney U-test is most commonly applied. Mann-Whitney U-test is a non-parametric test and t-test is a parametric test. So with more than 2 randomized group design or multi-group design, we can also have more factors. We can also have the masked group designs. This design is known as a randomized block design. In masked group design, all subjects are first tested on a common task and then they are formed into groups. The group thus formed are known as equivalent groups. Subsequently, the different values of the independent variable is introduced to each group and the mean scores of the dependent variable is taken of both groups. The matching variable is usually different from the variable under study, but in general, related to it, the 2 groups are not necessarily of the same size, although there should not be large difference in the number of subjects of 2 groups. That is in matched group decision. In matched group design, we may use 2 methods of matching. We may use matching by pairs, or you can use matching in terms of mean and standard deviation. Then you come to the within subject between all this matching, randomness, everything. We discussed on our between group design. Now we come to within groups of design, that is within subject, error variance, within subject design. Within subject design, it's also known as repeated method design, because the same individual is treated differently at different times and you compare their scores after they have been subjected to different treatment conditions. For example, a researcher wants to study the effect of color on reaction time, the investigator selects 3 colors, red, green, and yellow. Let us say that 10 subjects are selected for the experiment from the population of interest. After exposing them to different colors, their reaction time is noted and compared. That is all. Within subject design is further divided into 2 categories. There is 2 conditions within subject design and multiple conditions within subject design. The 2 conditions design is the simplest design, and the multiple condition design are involving multiple factors, multiple conditions. So now compare the between group and within group design. In the within subject design, each subject is the experiment. In the within subject design, each subject in the experiment receives a number of treatments or conditions, whereas in the between subject design, the subject receives the only treatment. In within subject design, the experimenter repeats the measures on the same group of subjects, and this increases the precision of the experiment by eliminating inter-subject difference as a source of error. Whether we will use the between group design or within subject design depends on the experimental conditions. When there are chances of practice or carryover effect of the treatment to the subsequent task, then between group design should be preferred. When we have smaller number of subjects and they are available for extended period of experimentation and number of treatment and the number of treatment is small, then we should prefer within subject design. So like this, the between subject design is having different type of uses. It has relevance in some situation, and within treatment design is also having relevant in different situations. And then you come to the factorial design. So in the factorial design, actually it is a very higher statistics. So here the factorial design is one in which 2 or more variables or factors are employed. In this factorial design, the set values of 2 or more independent variables are manipulated in all possible combinations so that they are independent as well as interactive effect upon the dependent variable can be studied. On this basis, we are using 2 or more independent variables and manipulating the variables with possible combination to examine their effects. The terms related to factorial design are actually many. The terms are factors. The term factor broadly used to include the independent variables that is manipulated by the investigator. So it is, if it is one independent variable, one factor, 2 means 2 factor or 3 factor. So the factor is the name for the independent variable. Then the other term used is main effect. The main effect is the simplest effect of a factor on a dependent variable. As I told you, in other cases like personality, extrovert, introvert, and the anxiety, high, low. So here the main effect, personality difference is significant, having significant effect or not. That is main effect. I told you the example earlier. Similarly here, in this factorial design, You can see the main effect. Main effect something different by interaction effect. So main effect is the simplest effect of a factor on a dependent variable. It is the effect of the factor alone, average across the level of other factors. So main effect in a factorial experiment is the effect of one independent variable averaged over all levels of another independent variable. Then the other is the interaction effect. And I told you the A-B effect or interaction effect. In my earlier example, A into B effect, that is A-B interaction effect. The interaction is based, I can say that the table when you are studying the result, the conclusion is based on the main effects of two independent variables. Maybe at times misleading, unless you take two consideration, the interaction effect of the two variables also. So we get here the main effect and also we get the interaction effect. Suppose a study has been done to find out the effect of exercise and diet on the behavior. So here you can see the main effect, the main effect of A diet A and the main effect of exercise we are measuring, and then we also measure the interaction effect, that is the effect between the benefit received from exercise and diet together on the interaction effect. So main effect indicates the effect of one independent variable significantly on the level of another independent variable. So in the main effect, we are indicating the effect of one independent variable significantly, and when we measure one's effect on the other, or effect of one independent variable on the another independent variable, that will say it is the interaction effect. And the interaction effect, as you see in the statistics, in the method, in the approach, this could be different types of interaction. The interaction could be antagonistic interaction, when the main effect is not significant, but the interaction is significant. In this reason, the two independent variables tend to reverse each other. There may be synergetic interaction, when higher level of one independent variable enhances the effect of another independent variable. That is synergistic interaction. There could be also selling effect of interaction, when the higher level of one independent variable reduces the differential effect of another variable. That is, one variable has a smaller effect when paired with higher level of second variable. That is selling effect. So all of these types of interactions are common in psychological research. So we can have here a randomization, which is a process by which experimental units are allocated to treatment. That is by a random process and not by any subjective process. The treatment should be allocated to units in such a way that each treatment is equally likely to be applied to each unit randomization. So each one is likely to be applied The blocking also is another. This is the process by which the experimental units are grouped into a homogeneous cluster. So we are making blocks. That is homogeneous clustering. So the factorial design, as we discussed, are very commonly being used. The factorial designs have different types also. One is within subject factorial design. When the researcher wants to study the effect of context on memory, he can use this within subject factorial design. There is also between subject factorial design. There is also both between within, that is the mixed factorial design. So the factorial design thus helps us or enables us to manipulate and control two or more ways or two or more independent variables simultaneously. This factorial design can study the separate and combined effect of numbers of independent variables. The factorial design is more precise than single factorial design. By factorial design, you can find out the independent or main effect of independent variables and interactive effect of two or more independent variables. The experimental results of factorial design or factorial experiments are more comprehensive and also can be generalized in a wider way. However, the factorial designs have some limitations. Sometimes when we have more than three independent variables, each with three or more labels are to be manipulated together, the experimental setup and statistical analysis become very complicated. In factorial experiments, when the number of treatment combinations or treatments become large, it becomes difficult for the experimenter to select a homogeneous group. So all this about the factorial design. Now come to the quasi-experimental design. This is another design to make a study. The word quasi means to a degree, not complete. Thus, quasi-experimental design is one that resembles an experiment but lacks at least one of the defining categories or characteristics. Not completely same with experimental studies. It lacks one variable at least. The quasi-experiment is a research procedure in which the scientists must select subjects for different conditions from pre-existing groups. According to Wikipedia, the quasi-experimental design are related to the setting of particular type of an experiment or other study in which one has little or no control over the allocation of the treatment or other factors. The term quasi-experimental design refers to a type of research that lacks the element of randomness or random assignment. This quasi-experimental design, sometimes called as ex post facto design, to which we have discussed earlier, that ex post facto design can also be To some extent, you can say it is also quasi-experimental design. In this ex post facto design, to which you call after the fact experiment, here we lack some conditions that we are using experimental design. Here the independent variable has already occurred. The experimental studies the effect of after the occurrence of the variable. For example, if we are interested in gender differences in verbal learning, we would have to conduct a quasi-experiment, because you cannot assign participant to the two conditions, male or female. We cannot create group of males or females, but instead select members from pre-existing groups. In other words, we can say that in a quasi-experiment, we do not manipulate variables, but we observe categories of subjects. Matching instead of randomization is used. So the difference between quasi-experimental design and true experimental design. In true experimental design, the experimenter has complete control over the experiment. In quasi-experimental design, the experimenter doesn't have any control over the assignment of subject to a condition. Secondly, in true experimental design, we manipulate variables. But in quasi-experimental design, manipulation of variables is not possible. We only observe categories of subjects. For example, if we want to study the effect of gender, then we cannot manipulate gender. We simply label groups according to what we think is the important difference between them. Thirdly, in quasi-experimental design, we present some independent variables to two pre-existing groups. We may not know whether the difference in the behavior was caused by difference between the groups or by the independent variable. A quasi-experiment leaves open the possibility that other differences exist between the experimental and control conditions, and thus permit other potential differences to remain. So the quasi design is less dependable design than the real experimental design or the true experimental design. There are many different types of quasi-experimental design. One is non-equivalent group or a post-test only design. Here the non-equivalent or post-test only design consists of administering an outcome measure to two groups or two program group and a comparison. Similarly, we are having another as a non-equivalent control group design. In this design, both a control group and an experimental group are compared. And also, thirdly, you can say that the separate p-test, post-test sample design. Here you make the p-test findings, then you compare with the post-test findings. Then you have something double p-test design. And here is a very strong quasi-experimental design with respect to internal validity. Because in a pre-post non-equivalent group, the non-equivalent groups may be different in some way because the program is given, and we may incorrectly attribute post-test difference to the program. The double p-test design includes two measures paired to the program. Consequently, if the program and comparison group are maturing at different rates, you can detect this as a change from p-test 1 to p-test 2. Therefore, the design explicitly controls persuasion maturation threats. The next way is the switching replications design. The switching replications quasi-experiment design is also very strong with respect to internal validity. And because it allows for two independent implementations of the program, it may enhance external ability or generalizability. The design has two groups and three phases of measurement. There can be also a mixed factorial design with one non-manipulated variable. There can be also interrupted time series designs, multiple time series designs, repeated treatment designs, counterbalance designs. So there are all sorts of designs, different types of quasi-experiment designs. Of this is counterbalance design is very common. We are using it in experimental laboratories also. In experimental different type of experiments. When you're doing different studies, sometimes we are using this counterbalance technique. These counterbalance designs are also called as crossover designs. So all these designs are quasi-experimental designs which are not as effective as the real experimental designs, but still then we use it. The advantages and disadvantages of the quasi-experimental design. The quasi-experimental design has a lot of advantages. Number one, in social science, where pre-selection and randomization of groups is often difficult, they can be very useful in generating results for general trends. The quasi-experimental design is often integrated with the individual case studies. The quasi-experimental designs are used when randomization is impossible. Utilizing quasi-experimental designs, we minimize threats to external validity. Since quasi-experimental designs are quasi-experiments are natural experiments, finding in one way or finding in one may be applied to other subjects also. This can help us to allow, this can allow us for some generalization to be made about population. This experimentation method is efficient in longitudinal research that involves longer time periods which can be followed up in different environments. The quasi-experimental design is often integrated with individual case studies. The figures and results generated often reinforce the findings in a case study and allow some sort of statistical analysis to take place. Let me go to the disadvantages of the quasi-experimental design. The quasi-experimental design, or you can say a quasi-experiment constructed to analyze the effects of different programs, might generate results that show that one program is more effective than the other. The results will not stand up to rigorous statistical scrutiny because the researcher also needs to control other factors. There is a lack of random assignment in quasi-experiment. Which may allow studies to be more feasible. But this also poses many challenges for the investigator in terms of internal validity. This deficiency in randomization makes it harder to rule out confounding variables and introduce new threats to internal validity. Because randomization is absent, some knowledge about the data can be approximated, but conclusions of causal relationship are difficult to determine due to variety of extraneous and confounding variables. Moreover, if these threats to internal validity are assessed, causation still cannot be fully established because the experimenter doesn't have total control over the extraneous variable. Thus, we can say that with all these disadvantages keeping aside, as long as the shortcomings of the quasi-design are recognized, the studies can be very powerful tool, especially in situations where true experiments are not possible. So lastly, I come to another type of design. The other designs, other correlational designs. So here we can go to different types of correlation research, that is association between variables, that is associated two variables like x variable, y variable. Suppose x changing, also y changing, this means both are associated. So this type of correlation approach are having this. First is association, which includes association between two variables and association between more than two variables. And secondly also, the correlation design are those that are used to predict the score on one variable using knowledge about the one on one or more variables. So you can say it as a predictor variable. So here we try to predict it's known as the criterion variable. By way of regression analysis, we can make this prediction. For example, there is a relationship between stress and health. If you know the stress score, By way of regression analysis, we can predict the future health status score also. These codes and designs as we are having been used in different tests have many advantages and disadvantages. The codes and designs are used in many cases because available data makes it easy to use. It is used as the foundation for other designs that permit more certain causal inferences. It usually doesn't involve repeated administration of behavior. It usually uses very realistic measurements of behavior. It has also many disadvantages. The major disadvantage of Colson design is that they leave the actual results. The major demerit is that they leave the actual region for the association found quite unclear. They say they are associated, changing in one is getting changing in other. So they say they are associated, but they are not very sure about the region for which they can explain the association. Rarely does a correlation study allow inferences about cause and effect. The correlation designs have directional problem. The causation is reversed from the expected direction. So we can say that there are so many, like one other design is the causal comparative design, like correlation design. There is another design, causal comparative design. There is another design where you compare the causes, the regression technique, the causal comparative research attempt to identify a causative relationship between an independent variable and dependent variable. However, this relationship is more suggestive than proven, as the researcher cannot have a complete control over the independent variable. So now we can compare the causal, comparative and correlation designs. There are many common characteristics, or you can compare them on some common points other. Both the designs, the causal, comparative and the correlation design, they are similar because they lack manipulation of an independent variable. They lack control over the external variable. In both the designs, the techniques used for the confounding variables are same. They don't have anything to in both the methods, matching or controlling techniques are used to control confounding variables. No controlling measure. In both the research, there is no possibility of manipulating the independent variable, like Olson research. Causal comparative research is sometimes treated as very descriptive. The causal comparative research involves comparing two groups but not the same with Olson research. The Olson research, on the other hand, does not look at differences between groups. Rather, it looks at the relationship. Causal comparative research compares groups, but the Olson research looks at one group having nothing to do with establishing definition of causality. In correlation research group, independent variable is labeled as predictor, but not in causal comparative research. Both designs differ on the scaling of the independent or dependent variables. Similarly, the comparison between causal variable, causal comparative, and experimental design are very clear also. The causal comparative and experimental research both are attempting or both attempt to establish cause-effect relationship, and both involve comparison. Both are in both, but there are differences between two methods. In experimental design, randomness of sample is there, and randomly they divide the sample in two groups. But in causal comparative design, no randomness is there. In experimental research, the independent variable is manipulated. But in causal comparative research, independent value cannot be manipulated. But when you evaluate the causal comparative research designs, it has a lot of advantages. Number one, for the behavioral science, causal comparative research is more fruitful than experimental study. Second, the experimental studies are more costly than causal comparative studies. Thirdly, causal comparative research to permit investigation of variables that cannot or should not be investigated experimentally. But despite many key advantages, the comparative research also have some limitations. Since the independent variable has already occurred, the same kind of control cannot be exercised. Then this is a great lacuna for this causal study. In causal comparative research, manipulation of independent variable is not done. So conclusion about cause and effect could be questionable. So now I come to the block 4, that is introduction including ethnography. So here this unit comes on to qualitative research. We are all reading earlier about quantitative research. Now come to the qualitative research. The qualitative research can be defined as a type of scientific research that tries to bridge a gap of incomplete information, systematically collects evidence, produces findings, and thereby seeks answer to a problem or question. The qualitative research helps us in providing in-depth knowledge about human behavior. There are so many types of qualitative research, like one is case study, the qualitative research. One is ethnography. The ethnography study is mainly an approach, a study focusing on a particular community. It is more or less a kind of closed field observation. and basically studies the phenomenon. Thirdly, the historical method. This method helps in understanding or analyzing the causal relationship. And fourthly, the grounded theory. This approach involves an active participation of the researcher. In the grounded theory, the researcher himself is also a participant. This grounded theory is very important. It helps in identifying anchors or codes that allow the key points. It helps in making implicit belief system. It consists of a set of steps also whose careful execution is thoughtful or thought to guarantee a good theory of explanation or good theory at the outcome. The data collection analysis continue throughout the study in a ground theory. Now I can give you the last point, that is the difference or the comparison between the qualitative approach and quantitative approach, or qualitative research, quantitative research. In the qualitative research, regarding general framework, it seeks to explore phenomenon using some structured method, what are the in-depth interviews, experience like that. In quantitative research, we seek to confirm hypothesis only. Here we use structured methods and questionnaire, survey like this. Regarding objectives also, the qualitative research aims to describe variation or explain relationships, describe behavior, but in quantitative research, it aims to quantify variation and predict causal relationship. And thirdly, the questions used for data collection are open-ended in qualitative research, and in quantitative research, the data is represented in form of numbers and graphs. Sorry, in the quantitative research, the questions used are close-ended. Here, open-ended is close-ended. And in qualitative research, the data are represented in form of notes, recordings, and videotapes. In quantitative research, the data are presented in form of number and graphs. The research design in case of qualitative method allows flexibility. The questions used for the data collection differs individually, but in quantitative methods, it's not like that. The design is predetermined and stable from the beginning. The questions used for data collection are structured. So here there are some relevance of quantitative research in psychology also. It's very relevant. So we can use also ethnography. That is a study also. The ethnographic study. The ethnography is actually, the method is ethnomethodology or methodology of people. This is relating to culture, and we are having here symbols, cultural patternings, classic knowledge, and seasonal reductions involved in ethnography. The ethnographies are different types: microethnography, macroethnography, emic perspectives, and ethic perspectives. So actually, lastly, we can go to the grounded theory. It's very important. Grounded theory indicates the researcher himself is involved here as a participant. And the grounded theory, and the last portion, the time is over. I'm going to tell the last portion, that is reporting and evaluating in qualitative research. The steps of evaluating research, that is reading the overall data, categorizing the data, naming or labeling the categories, identification of the causal relationship, recording or filing the data. All these are there. The steps involved in reporting. The steps of reporting or steps of preparing a report are many, like preparation of the content report, review and discussion of the report, preparation of the executive summary, scope of future research. When you make a report writing, then you must see that you are having like this. You see the page 40 if you have the books. That's very important. When you write a report, research report, you look at the contents. Like number 1, title page. Number 2, table of contents. Number 3, executive summary. That is summary of your work. Number 4, purpose of the report. Number 5, contextual background of the research. Number 6, methodology. That is what have you used, like a sample, scale or questionnaire, type of data, that is all methodology. Number 7, results and findings. Number 8, interpretation and conclusion. Number 9, limitation of the study. You have made a study, but what are the limitation? Number 10, recommendation. How you just recommend this for future studies, implication, the benefit. Number 11, references. And number 12, appendices, anything when enclosing. So all these are regarding a report under evaluation. There are some do and do nots in evaluating. While evaluating, analyzing and reporting data, you do something. The analysis should be clear, specific. The analyst should quote the data for their convenience. The analyst should frequently use diagram. The analyst should draw conclusion on the basis of present study and other later study. And other when required, the analyst should develop policies for further evaluating or confirming the data. And what you should not do, the analyst should not depend fully upon research design. The analyst should not interview about only the successes. The failures can also be significant to providing information. The analyst should not completely depend upon questionnaires, as much of the information can only be available through observation and interviews. So with this, I just cover the portion hurriedly. So maybe in the process of hurriedly covering the course, some portions would have been overlooked. So now I have told you earlier, again also telling, now you can go to the book, and if necessary, or if you want to be clarified on some concepts further, you can contact me over phone. I can clarify. Right? Thank you very much
sir.
for me.
Sir,
So,
next class रे कौन पढ़ा है वो?
Eh?
Next class रे कौन पढ़ा है वो sir?
How to class बनाई?
Okay.
ना मोर नहीं हो. ଆଉ କରିତେ ମୁଁ କହିପାରିବିନି, ମୋ ପାଇଁ ମତେ ଏଥିରେ 2 ଦିନ 25-26
ଆଜ୍ଞା sir. ଆଜ୍ଞା sir.
ଯଦି ସେ ଏକ୍ସଟ୍ରା କ୍ଲାସ ଦେବେ, ତମେ ଚାହିଁବ ଯେ ଏକ୍ସଟ୍ରା ଦେବେ ଯଦି ତମେ ଦେଲେ ମୁଁ କ୍ଲାରିଫାଇ କରିବି ଆହୁରି। ତମ କ୍ଲାସ ଯଦି କିଛି ଅଫଲାଇନ ହୁଅନ୍ତା ବେଟର ହୁଅନ୍ତା ଟିକେ, ତ ଅଫଲାଇନ ହଉନି, ଅନଲାଇନ ହଉଛି। ଯାହା କହିବା କଥା, ଯଦି ତୁମେ ମତେ ଡାଉଟ୍ କହିବ, ଏହା ଡାଉଟ୍ ଅଛି ବୋଲି ମୁଁ ସେଟାକୁ ବୁଝେଇଦେବି। ଆଉ ଯଦି କ୍ଲାସ ପାସ୍ ହବ, ତମ ନମ୍ବର ମତେ ଯଦି ପଠେଇବ, ମୁଁ ତାକୁ ଜଣେଇଦେବି।
ଆଜ୍ଞା sir.
ଆଉ କଣ ପଚାରିବ? You can ask me anything you like.
Sir, କାଜି methodology ର ଗୋଟେ example ଦେବେ sir?
କଣ?
काजी एक्सपेरिमेंट रो जो मैं जो कहूथिले आपण one program is better than other sir
क्वाजी एक्सपेरिमेंट
तार एग्जांपल टे दरकार सर कि बुझिया को बेटर अंडरस्टैंडिंग होता
मु कहू शुणा माने ऑलरेडी तुमरो गोटे फाइंडिंग पाई सारचो
सर लाइक एप्लीकेबल एटा एप्लीकेबल कोठी सर को जगह रे अप्लाई करा हो ए एक्सपेरिमेंट
ए मु कहू शुण तुमरो क्लास रे तुमे रहुच डिस्टर्ब देयर डिस्ट्रैक्शन देयर इनअटेंशन गोटे स्कूल पिलाटे रहुची इनअटेंटिव तुम देखियो तो रहुची इनअटेंटिव तो तुम देखो कौन करुच कौन तार कज हो पारे कहीं इनअटेंटिव है सेटा को तुम कज कंपेयर कर आ गोटे क्या कंपेयर कर कि आउ जोटे केस कंपेयर कर माने इनअटेंटिव जो सम कॉमन पिला संगे कौन से फैक्टर अच्छी आगे से फैक्टर अच्छी तो कौन फैक्टर अलग है फर यहाँ क्वाजी एक्सपेरिमेंट तो ये कौन क्वाजी एक्सपेरिमेंट माने यू आर नॉट एबल टू कंट्रोल द वेरिएबल तुम्हें क्लास रूम कंट्रोल कर पारन तुम्हें सेमती ओपनली से गोटे जो चली तार जो बिहेवियरल प्रोब्लेम होउची तमें यू आर नोटिंग डाउन द बिहेवियरल प्रोब्लेम तमें निजे आसाइन करूछ को कज हो पारे कौन बेटा है लाइक एक्स पोस्ट फैक्टो माने स्टडी तो करूना गोटे माने देकरी काम क्वाइट एटमॉस्फेयर पढ़ी गोटे दउछ गोटे कंट्रोल कंपेयर करछ कंपेयर कि नहीं तमें गोटे तार बिहेवियरल प्रोब्लेम जो हेची तार कज तुम्हें माने कहती रेट्रोस्पेक्टिव पर्सपेक्टिव स्टडी कहती मु तो पछरे कौन कारण रही स्टडी कर अच्छा क्वाजी एक्सपेरिमेंट कौन होची तुमरो कि इंडिपेंडेंट वेरिएबल गोटे केमती तुम्हें कंट्रोल तो नहीं वेरिएबल कंट्रोल कर पारनो किछि कि इंडिपेंडेंट वेरिएबल तुम्हें मूव कर पारनो मैनिपुलेट कर पारनो जा हे जाइछि तो को वेरिएबल जोगो एटा हेछि ड्यू टू इंडिपेंडेंट वेरिएबल और ड्यू टू अदर एक्सटेंडस वेरिएबल गोटे पिला अटेंटिव होउनी मे बी ड्यू टू टीचर इज नॉट टीचिंग वेल or maybe there is noise, maybe some other sound coming, maybe hot temperature, the fan is not moving. So many causes are there, and you don't have any control. But you are going to analyze the behavior by going into all these factors. What could be the possibility? So quasi experiment माने experimental माने जोटी इंडिपेंडेंट वेरिएबल और डिपेंडेंट वेरिएबल रहउथबो संपर्क जोटी कंट्रोल कंडीशन रे इंडिपेंडेंट वेरिएबल को मैनिपुलेट करा जिवो क्वाजी एक्सपेरिमेंट रे देयर इज नो कंट्रोल ओवर द सिचुएशन एंड देयर इज नो वे हाउ टू मैनिपुलेट इंडिपेंडेंट वेरिएबल बट द फाइंडिंग्स आर आल्सो साइंटिफिक लॉजिकल बिकॉज़ एया हेची बोली तार अटेंशन नउनी कि आगुरी यह होनुला बोली बड़ी साउंड नथिला कि फैन बंद नथिला तार आसन होउथिला ता माने ए जो तार बिहेवियर प्रॉब्लम हैला मे बी ड्यू टू नॉइज और मे बी ड्यू टू हॉट टेम्परेचर बुझो नहीं
सर
यस एनीथिंग एल्स कौन डॉक्टर रुचा
Yes, sir.
Did you come in the first class?
Yes, sir.
Acha, I didn't notice that. Good. मते तुम तो फोन में कैसे दबो बोली देखो
हाँ सर मु व्हाट्सएप रे मेसेज कर दोची सर अबे कर दोची सर
डॉक्टर आयुर्वेदिक डॉक्टर सुनबा टिके मु समझ के कहूछ मते ऑल ऑफ यू could give me your numbers so that if necessary I can communicate to you that part I can also give you clarify any doubt in you how going to कहबो निमिषा
Yes, sir.
I think I didn't see you earlier
Yes, sir. I have attended all the classes.
All the classes? Oh, good. You are working somewhere working?
I'm a working career counselor.
Where?
I have my own setup, and I had worked for a few years at school as well. Right now, I'm on sabbatical for 2 years, so I have joined the course.
Oh, good. Good. Where you are now?
I'm in Bhubaneswar only, Patia area.
Patia area. Acha, acha. Okay. I will communicate to you. I will contact with you also.
Thank you,
You
sir.
are doing on counseling good. Shantanu, you are where?
Sir,
Shantanu, you are from?
presently I'm at Bhubaneswar, sir.
Where? Bhubaneswar, where?
Patia area, sir. I'm also staying in Patia area.
Oh, good. Then what are you doing?
Sir, I'm an engineer by profession,
Good.
and just felt like means I had a I means much before I thought that I should learn psychology, and I'm purely learning
Good.
psychology for me.
It's strange. The engineer people, they are having something like technical mind. They are in love with psychologist people. The psychology actually giving in them more pleasure and thrilling for them. Good. So, Shantanu, I must be in contact with you also.
Right, sir. Right, sir.
Okay. Maheshwata, today you are here. Maheshwata, not here.
Yes, sir.
Did I talk to you earlier?
No, no, sir. But I did some classes, not all classes.
Exactly. I not seen your name also there.
Yeah, yeah.
So you are in Bhubaneswar.
No, I am from Berhampur.
Oh, that happens actually.
Yeah,
Acha, acha. Are you working somewhere?
yeah. I am working in a NGO, like working with special needs kids.
Oh, good. Acha, ठीक अछि. Any doubt you can talk to me also, right?
Yes. Yesterday I took your number, so I will
Okay.
let
Talk to
you.
me.
Yeah.
Then good. Very glad to see you all. Still
Thank you, sir.
waiting. Some of you have left also,
Yeah.
but you people, you 7-8 persons are still. We are here to communicate, to interact. Thanks to you all. Will you ask me anything, or should we go?
Sir, we have another class at 2:30.
2:30?
Yes, sir.
Now, sir, we have another class now.
Oh God! Who will take the class?
Yes, sir.
कैसे? ये नबो?
Class.
Not sure.
No, sir, just telling you the name, sir.
Okay, ठीक अछि. Anyway, we can talk later.
Sohani
Hopefully,
madam
I
name,
told
sir.
you all to give me I have given my WhatsApp number also. My number is
Sir.
WhatsApp number. You can send your numbers. We can be in touch also, right?
Sure, sir. Sure, sir.
Okay. Thank you very much.
Thank you, sir. Thanks for your time,
Okay.
sir. Thank you.
Okay.
Thank you, sir.
Thank you,
Okay.
sir.
Oh, okay.
Thank you, sir.
Welcome. It's very good to interact with the people. You are all very good.